The main huge problems. There's basically 3 or 4 big topics. Usually 3 are the main ones, but this is one monster one. It was finding the tangent line and finding the slope of the tangent line of some kind of curve. And kind of where this started first was originally taking a circle and drawing a tangent line to that circle and trying to figure out what the slope was. And that was pretty basic, pretty easy to do back in the day. If I had a circle like so, and then I tried to find the tangent line of this point right here. And this is probably a little bit more geometry than you need. But if I were to take the radius of this guy, the radius and the tangent line are perpendicular. So if I can figure out the slope of this, which is usually pretty easy, whatever the radius is, I can just figure out the slope of that by doing that opposite reciprocal. That's if it's on a circle, though. It gets a little more complicated if I have a curve. So for example, if I have some curve like this, and I want to find the slope of the tangent line right here. A little bit tougher because I don't have things to go off of, okay? So that's going to be the hard part for today. So what we want to try to do is, and we kind of hinted at this a little bit when we first started this calculus stuff, is to, instead of thinking about it as a tangent problem, we're thinking about it as a secant problem. And the secant line, the idea of a secant line is it goes through more than one point, okay? So if I take this graph, and I'm just going to draw some random graph like so, and I want to find the slope of the tangent line right at this point. What I do is actually take another point out here and find the slope of this secant line. Okay, so that's what I'm actually looking for, is finding the slope of that secant line. So how do you find the slope of a line? Well, close. Yeah, y equals mx plus b. That came from somewhere, but the m part. Yeah, the rise over run. Okay, and how do you calculate that? Yeah, that's probably the most common. y2 minus y1 over x2 minus x1. And there's a couple ways to write this. It depends on what book you're going out of as far as notation goes. But a lot of times they'll put a little triangle in front of the y and then divide it by the triangle in front of the x. If you've taken physics, you might have seen those before. But the triangle is actually a Greek symbol. And actually it stands for delta. And delta is Greek for change. So this is actually the change in y over the change in x. So we're finding out how much y is changing over this span right here. That's the rise part. That's how much it's rising. So if I were to draw a little box in here, the delta y would be this piece right here. It's how far up or down this guy is changing. Okay? How far I'm changing in this direction is how far the x value is changing. So this is going to be delta x. Okay? So that's going to be your delta x right there. Now, some books use delta x. Some books use h. I'm an h guy, so our book uses delta x. So I'm not going to use what our book does, unfortunately. So if you're referencing like the notes in the front, sometimes, there's like notes that you guys can look at. Nobody ever looks at those. What? You know what I'm talking about. They do a slight bit different. I think that their notation is just a little bit more complicated. So I'm going to try to do it in a simpler process if I can. Okay? So they use delta y, delta x. I'm going to try to do this in a little simpler method if I can. Okay? So let's go ahead and draw a nice little curve. I'm going to draw a pretty steep one just so we can get a good value, a good visual of what's going on here. Okay? This one's called the secant line. And that just means it goes through more than one point. Now the idea is if I want to find the slope of the point right here, of the tangent line right at this point, the idea is I'm trying to drag this point closer and closer and closer to this. So I'll have multiple secant lines. As I take this secant line and I get it closer and closer and closer and closer and closer, I want to eventually get it to where I'm right on that. Now that kind of concept is a limit, as I'm getting closer to one specific value that I can't actually find. That's the limit idea. Okay? So what I want to try to do is I'm going to put this on a graph. So there's my graph right now. This point right here, this point I'm going to call my x value. Okay, so this is going to be my x value. The point right there is actually going to be x f of x, if I thought about it in a point. Okay, x is whatever my x value is. I get to pick whatever I want. F of x is just the y value, so that's how high it is. That's how tall it is. Okay. Then what I'm going to do is I'm going to come out a certain distance. I'm going to come out to this point right here, and I'm going to say this distance right here is going to be h. So if I were to build a right triangle right here, okay, this distance right here is thought of as h. Whatever that distance is h. Now, they use delta x in some books. I like h. It's arbitrary, the fact that they picked h. But, well, you'll learn a little bit later why they picked h. But some books use delta x. We're going to try to avoid that. That means that this x value right here is this x value plus however far I went on h. So this x value is x plus h. Okay, so I've added this distance of h onto my x value right here. Okay, which means this point right here, if I were to write that as an ordered pair, that means that my x value is x plus h. So I've got x plus h. And then my y value is f of x plus h. Okay, so I plug this in for my function. So it's going to be f of x plus h, like so. Okay, so those are my 2 points that I'm looking at. I'm looking at this point, I'm looking at this point. Now, to put that together in a slope, I'm going to come down here to my slope. Slope is, let's see, y2 minus y1 divided by x2 minus x1. So it's basically the change in y's over the change in your x's. And now I'm just going to plug into that formula, into the slope formula, my points that I have. I have this point and I have this point. So I want to plug those points in. Okay? So I'm going to first take the second y. Okay? So what's my second y that you guys have written down? F of x plus h, right? So this is going to be f of x plus h. That's the first y2. And then I subtract y1. So I'm subtracting my first y value. So what's your first y value? F of x. So subtract f of x. Okay? Divided by x2. Okay? What's my second x value?
X plus
h. X plus h. And then I'm subtracting the first x value.
X.
Just a regular x, okay? They call this the difference quotient. I wonder why they call it the difference quotient. Let's see, difference, what does difference mean? Subtract. And quotient means divide. Okay, so they call this the difference quotient. Anyways, this does a really cool thing for you. This actually finds the slope. This actually finds the slope between 2 points. Okay? Now, what happens on the denominator here? We got x plus h minus x. It's just h, right? They cancel. So we just get h. So my slope here is going to be f of x plus h minus f of x, and then divide that by h. Okay, that right there is a huge deal. This is still called the difference quotient, even though I'm not really subtracting from the bottom. I already did the subtraction, but they call this the difference quotient. Now this finds the slope for me at any point that I want to find. Okay, this formula will be a big deal in a little bit. Okay, now the idea is I want to find the slope of not just this secant line right here. The problem is, the idea is I want to find the slope at this point right here, which is kind of an odd thing to do. That means that I have to take this line right here, take this secant line, and change where that h is. Okay, notice what's happening if I build a triangle right here. This is now a different h, right? It's a little bit smaller. And then if I go, all right, pick this point right here, and then I've got this secant line. That picture's going to get messy. And I've got this h. So what is h doing? H is getting smaller and smaller and smaller and smaller. Okay? Now, here's the kicker. What happens if I go h goes to 0? Yeah, it blows up, right? If I got h is 0, that means I have the same point that I'm finding the slope at. Well, that's kind of weird. If I go the limit as h goes to 0 of this function, f of x plus h minus f of x, and then divided by h. Well, can I just do direct substitution there? Can I just plug a 0 in there? No, why not? Because what? It's undefined. Okay, it's even more than undefined. Yeah, if I plug a 0 on the bottom, what happens if I plug a 0 on the top? What happens?
0.
You get 0, exactly. It's weird. Well, you plug a 0 in for h, so that'd be f of x plus 0, which is f of x, minus f of x, so that'd be 0, right? You're subtracting the same thing. So 0 over 0, that's kind of that weird indeterminate. We've seen that before. They call that an indeterminate form, which is kind of funny. Right. Now this right here, they call this the formal definition of what's called the derivative. Have you guys heard of that word before?
Yeah.
Talked about it a little bit? Yeah, what's up?
Okay, wait, I'm not kind of confused on the top part of there. If h is 0, what if x is something else? Like
X can be whatever it wants.
if it's
Perfect.
2 is 0, it would be 2 times f.
Say it again?
Wait, I'm confused how the top can be 0.
If I were to plug a 0 in right there, it would be f of x plus 0 minus f of x, right? And then x plus 0 is just x.
Oh, okay.
Right, and then when I subtract the same thing, I get 0. So that's why it's 0 over 0. Indeterminate form, just a nasty thing for us. It's a big problem in calculus for us to have that indeterminate idea. Now, this is what's called the derivative, is finding this guy right here. And the derivative does a ton of stuff. Man, we're going to do a lot of derivative stuff before we're done. But let's start out with the basic thing. The idea here behind all of this is I'm finding the slope at any point on a graph. That's what I'm doing. So this formula right here is what I call like a slope generator. Okay, this formula, this equation, will generate slope at any point that I want, no matter what. Okay, let's start out with one that's very basic. Let's start out with f of x equals 2x plus 1. Okay, a pretty basic equation. And I want to find the slope of the tangent line at, let's say, the point 3. What if we have to throw in 3, 7? 3, 7 is a point on there, right? Yeah, sounds right. Cool. So let's say I want to find the slope of the tangent line of this graph right here. Now, all this is a slope generator, And graphically, this is going to feel a little bit weird. But if I were to graph this 2x plus 1, I would go up 1, and then I would go up 2 and over 1. And that would be my graph right there. You guys okay with that? Okay. Now let's say I picked a point on this graph. Let's say I picked this point right here. What's the slope right at that point of the graph?
2.
It's 2. What about this point? It's 2. What about this point? 2. Anywhere around here, the slope is 2. Okay. So what I want to try to do is I want to use the difference quotient, this big mess right here, on this function. Hopefully I get 2 everywhere. That's my goal. Okay. So we need to do a little bit of manipulation on this. So we're going to find the limit as h approaches 0. Limit as h approaches 0 of f of x plus h. The nice part about this formula right here, it is a purely plug and chug formula. It's very simple to do. It seems convoluted and hard right now, I know, because we're in a theoretical world right now. But we can just plug it in. That's all we have to do for this one. We're going to do f of x plus h. I'm going to plug in x plus h into my f function. Okay? So I'm going to plug this right in there for that x. So I'm going to go, the limit as x goes to 0 of 2x plus h plus 1. Notice what I've done so far is I've plugged in x plus h right here into my f function, which is this guy right here. So I just purely plugged that into that x right there. That's all I've done so far. Okay. Now it says subtract the function. Subtract f of x. Okay. So I'm going to subtract the entire function. Okay. I'm going to run out of room, so let me erase this. Okay. I'm going to subtract the entire function, which is 2x plus 1. And then I want to divide all of that by h. Okay, so I'm literally just plugging this in. This never changes. This is always the same all the way through forever and ever and ever. Okay, the definition. Okay, the line you're doing. Plugging this into the x, right? Subtract the function and divide it by h. Now we just do a little bit of simplifying. Okay, we just have a little bit of algebra to go here and we're done. Okay, so I'm going to distribute the 2 here. We got the limit as h goes to 0. Distribute the 2 gives me a 2x plus 2h plus 1 minus 2x minus 1. All divided by h. And then hopefully good stuff happens. It will. Let's see, 2x and the negative 2x cancel, like terms. 1 and negative 1 like terms, cancel. So all I'm left with is 2h over h, which is 2. So I got the limit as h goes to 0 of 2. So what's the limit as h goes to 0 of 2? 2. The answer is 2. Okay. Now, what was the slope at any point on that graph?
2.
2, right? Ah, good. I'm glad it worked. Okay. It should work. Any point on that graph, the slope of the tangent line is going to be 2. Now, that was a fairly basic one. Obviously, they're going to get a little bit tougher. Let's go a little harder. Okay. Yeah.
I'm confused with how you got 2 as the answer for the limit of h.
Well, I can just do direct substitution. If I plug the 0 in for h, what would be left over? There's no h to plug into, right?
Oh.
Right? So if you could think of it as, I guess, h to the 0 power if you really want to. But there's nowhere to plug in the 0, so it's got to be a 2. Now think of this as a function right here. If this is a function, that's the graph that looks like this, 1, 2. That's this line right here, right? Anywhere where h is, who cares what h is, right? The value is always going to be 2. No matter what, my y value is going to be up to 2. Okay? Question? Not yet, maybe.
Why is that a tangent line if it was this?
If it was the actual line, it's kind of, that one's kind of a weird one to see. Let's do one where you can see the tangent line a little bit better. Okay. Let's do the one like this. Let's do f of x equals, let's go x squared plus 1. Technically not a tangent line. It is the line. This one will have tangent lines everywhere, so it'll make it easier to see. Okay, and we're going to find the slope of the tangent line. At a couple different points. Let's go a super hard one first. Let's go 0, 1. It's going to be tough. And then we'll go 1, 2. And then negative 5. Ooh, what's negative 5? 26. That's right. Okay, now what I want to do is find what they call the derivative. And we're going to do a ton of finding derivatives in here. In physics, you've actually probably already found derivatives with like acceleration and velocity. Have you guys talked about all that? And position and all that stuff. All that's derivative and integration. That you guys are doing that whether you know it or not. The math behind it is this. If I want to take this function right here, f of x equals x squared plus 1, if I want to find the derivative of that, the big main notation that you'll see, it looks like this. It's f prime of x. And that's how you read that. You read that as f prime of x. So it's a little kind of hash mark on it. Okay? Now there's a couple ways to write that. This is the most common way. I'll show you a couple other variations just so you don't get confused when they throw some notation at you. Okay? Now what I want to do is I want to find the derivative of this function right here, which is basically a slope generator. Okay? This generates slope for me. It finds slope at any point on the entire graph. Okay? What I do is I do that same exact limit process. I do the limit as h goes to 0. And then I do f of x plus h minus f of x. And then I'll divide all that by h. Okay, so literally this is kind of just a plug-in type formula once we've figured out where the heck it comes from. Okay, but this is purely just finding slope. That's all we're doing here is finding slope, rise over run. The tricky part is we're finding rise over run of 1 point. It's kind of an odd thing to do. Okay, we can't really do that. We have to have 2 points, but then we just get close. All right, so let's go ahead and plug it in. We've got f of x plus h, so I'm going to plug in x plus h, plug that in for my x function. Okay, so I'm going to plug that right in there for that x. It's going to give me x plus h squared minus f of x, plus 1. Okay, that's the x plus h plugged in. So I literally just plug that into this function right here, x plus h. Now I'm subtracting f of x, which is the function. So subtract the entire function, x squared plus 1. And we divide all of that by h. Okay? Everybody kind of seeing where we're plugging stuff in there, maybe? You'll just kind of get the pattern as we do a couple of these a little bit more. Now we're going to simplify this a little bit, so I'm going to square that. Okay, most common mistake is people just put x squared plus h squared. That's wrong. All right. Okay, we've got to go x squared plus is going to be 2xh plus h squared, if you were to FOIL that out. Plus 1 minus x squared minus 1. All that's divided by h. Now, if a bunch of stuff doesn't cancel when you're doing these, you're doing it wrong. You did your initial plug-in probably wrong. Okay, stuff should cancel out beautifully on this. Okay. All right, so let's go ahead and figure out what we're headed towards, what we're going to. Looks like my x squared and negative x squared cancel. My 1 and negative 1 cancel, and that's about it. Okay, so pretty much everything that doesn't have an h cancels. I'm left with a 2xh plus h squared, and then dividing that by h. Okay, x squared cancels, and then the 1's cancel, and that's what I'm left with right there. Okay. Well, I still can't do the limit as h goes to 0 here. If I plugged in a 0 for my h, I like doing that direct substitution as h goes to 0. I can't plug in a 0 because it's 0 over 0, right? So what else could I do with this guy? What do you guys think? Yeah, factor an h out or cancel an h out of each term. Okay, so I'm going to take an h out of here, and an h out of here. Okay, so I'm doing the limit as x goes to 0 of 2x plus h. Okay, so I took an h out of all of them. Or yes, you could factor an h out if you did h and then 2x plus h and then divide that by h and then cancel the h's out. That's fine. It's up to you.
Wait, shouldn't it be
Is it
h
h
to 0?
to 0 or x to 0? Like goes to 0.
Oh, thank you. Oh, yeah. H, my bad. Sorry. We just did limits, all of the limits where x goes to 0, so sorry about that. So we're going as h goes to 0 here. As h goes to 0, I just plug in a 0 now. And there's nothing stopping me from plugging in a 0 doing direct substitution. Okay, so what's left over if I plug in a 0 for h right here? 2x. Okay, so 2x right there, that is your derivative. Okay, that is what I call your slope generator. This equation right here generates slope for you at any point on the graph. Okay, so my derivative function is this guy right here is a 2x. Okay, so that's my original function. That's the derivative of the function. Okay, this is a slope generator. That's what this does. Okay, yeah, what's up?
Can I see the bottom?
You sure can. Good. Integration, my little symbol that I put in front of the notes, is going backwards. Is if you have the slope generation equation and then going. Okay. So we'll get there next semester. The little symbol right there just means go backwards. That's what it means, which is brutal hard. We'll get there in a bit. All right, so I'm gonna erase some of this stuff just so I have some room. Okay, erase the basics. Okay, so I've got my derivative right here. I got the derivative of x, which is f prime of x, is how you read that. The derivative of x equals 2x. Okay, so now if I want to find the slope at any point on the graph, I can just take my values right here and I can just plug them in. Okay, I've got the point 0, 1. Let's find the slope of the tangent line at 0, 1. Now the slope of the tangent line, isn't that right here? So what should that slope be? Should be 0. I mean, just intuitively on the graph, looks like my slope of that line is 0. Okay, so that makes sense to me. Now, if I want to plug that in, I just go to f prime of 0 equals 2 times 0, which equals 0. Okay, so 0 is the slope when x is 0. Okay, the y values don't really matter yet. Right now, they don't matter. Okay, they will matter later. Okay, now let's find the slope of the point at 1, 2. Okay, so if I go over 1 and up 2, that's this point right here. I want to find the slope of this tangent line right there if I can. Okay, well, I can intuitively kind of see what the answer is going to be, maybe. Now, if I plug in a 1, 2 right there, let's see, I'm going to find f prime of 1 equals 2 times 1, which equals 2. So the slope of this line right here is 2. So I got m equals 2. Yes, my graph's not perfect, sorry. But I'll show you a way to kind of check your answer on that in a second. All right, and then the last one, find the slope of the point at negative 5, 26. Negative 5's here, up 26 is probably going to be way up here somewhere. So I'm going to have the slope of this tangent line. Looks like a pretty steep negative number if you ask me. Okay, so I'll plug that in. So that would be f prime of negative 5. And I get 2 times negative 5, so I get negative 10. Okay, so negative 10 is the slope of this line right there. Okay, so this equation right here is purely a slope generator. It generates slope for you at any given point on any graph that you want to do. Okay? All right, let's go a little harder. A little bit. All right, let's do, how hard do we want to do? Let's go that hard. You guys ready to get your butts kicked? Yes. We got like 2 or 3 more. Okay, see if you can at least get the plug-in of this. Okay, the limit is h goes to 0. We got f of x plus h minus f of x over h. Whoa. Somebody's getting hurt. That's bad. That's bad. That's awesome. All right, I'm going to get my setup here going. Oh, is this gross? This is gross, isn't it?
Shouldn't be gross. These are the X.
Everybody got that? Alright, this looks so easy. Ooh, except for that nasty part. That's gross. How do I do that? There's a shortcut to that, isn't there? Binomial. Yeah, it's that binomial up there. Nobody remembers. I know. Remember that choose stuff? It was like 3 choose 0, 3 choose 1, 3 choose 2. Oh my god. All right, we're not gonna do too many of these. Just so you know, the third power is the highest that I will give you. Just so you know, so you can use the shortcut pattern. There's a shortcut pattern, a little bit using Pascal's triangle, but it's going to be x to the third plus 3x squared h plus 3xh squared, and then plus h cubed. Hopefully you got that if you cubed it all out. Okay, now if you had to do it the long way, which is fine, you could square x plus h, FOIL that out, right, get a trinomial, and then multiply that by x plus h again, and you should get that simplified version right there. Okay? But it basically is Pascal's triangle because it was 1, and then it was 1, 2, 1, and then 1, 3, 3, 1. so on and so forth. The nice part is most of the time when you're cubing it, it's just going to be x plus h, so you can go to a little shortcut. So. All right, anyways, let's go ahead and finish that. Hopefully you guys got that for the first part. Distribute the 2, so you got plus 2x plus 2h. And then minus, distribute the negative, so it's x to the third minus 2x. And all this is divided by h. Just stuff cancel. I hope. Some cancels. Not everything's going to cancel here, but some stuff cancels. Okay. Looks like my x cubes cancel, so those are gone. Anything else? My x's, so I got 2x and a negative 2x. Okay. Anything else? No. Any like terms I can get together there? Not really. Okay. The nice part is, and this should happen all the time for you guys, is I should only be left on the top with terms that have h in it. If I don't have an h in every term there, either you missed a like term, you missed a parenthesis, you missed something, so you kind of catch yourself a little bit there. Okay, so I've got 3x squared, h plus 3x h squared, and then plus h to the third, and then plus 2h. All that's divided by h.
Beautiful.
Okay, now we can cancel an h out of every single term, or factor an h out of the numerator, and then cancel it with the denominator. But I'm just going to take a power off.
Minus 2h?
It might be. No, I think it's plus 2h. I think it's plus 2h. Because I got a plus 2h right here is where it came from. And that came from the 2 distributing to that. So I think it's positive.
Oh, right.
I think I'm good. Okay. So now I'm going to take an h out of all of them. So it's going to give me a 3x squared plus 3xh, and then plus h squared, and then plus 2. Right? You guys get that? Maybe?
Yep.
Now I'm doing this as the limit as h goes to 0. Which is kind of nice. That means that every term that has an h in it is going to go away. Okay, so this one has an h in it. If I plug a 0 in here, that's gone. Plug a 0 in here, that's gone. So I get, what's like 3x squared plus 2. Awesome. So 3x squared plus 2, that's the derivative of this function.
Wait, how'd you get 3x plus 2?
If I plug a 0 in for h, both of these go away. So all that's left is the 3x squared plus 2. Okay, yeah, what's up?
So did you take h out of each one because you divided it by h?
Yes, exactly.
How much away from h?
I did. I take away one h away from each. So this one had one h, so it was completely gone, right? This one was squared, so it had two h's, so there's one left. Here I had 3, so I took 1 off, so 2, and there's 1, so I have none left there. Okay? All right, now this is my slope generator. Now, I don't want us to have to do a bunch. Plus, I want you to maybe just think, fast forward just a little bit. My derivative of this function is 3x squared plus 2. Okay, I'm going to leave it at that for now. Okay, are you guys all got the bottom? Everybody's okay on that? I can erase that? Because I want to do a couple more things with this. Okay, we're good? Okay, good. I want to erase all that stuff. Okay, now I want to find out a couple things. One, I want to find the slope at certain points. Okay, so if I were to graph this graph, let's just go ahead and graph this one and see what it looks like. Go to my y equals, clear that out. I'm going to go x to the third, so x to the third plus 2x. And I'm just going to go zoom 6, see what it looks like. You guys can all throw that on there. It looks something like that. Okay. Now what I want to do is let's find the slope at a couple points. Okay. For example, I want to find one point. Let's say I had the point 1. If I plug in a 1, I get 3. So there's the point 1, 3 on the graph. Let's just double check that value 1, 1, 3. Okay. So 1, 3 is a point on the graph. I want to find the slope right at that point right there. Okay. So my graph looks like this. I want to find the slope right at that tangent line. So if I just plug in a 1 right there, that's going to give me f prime of 1. Or f prime of 1. Said it right. Wrote it wrong. Is 3 and then 1 squared plus 2. So my slope for this one is going to be 5. We'll be okay with that? So the slope of my tangent line is 5. Now let's say I wanted to write an equation of a line that's tangent to that point. Well, that'd be a y equals mx plus b. Right? Bring back some bad memories here, I'm sure. Right? If I want to find, let's say I want to find the actual line. I want to find the equation of the line that's tangent at the point 1, 3. Okay? Well, I know what the slope is now. Right? What's the slope? 5. Okay, so I've got y equals 5x plus b. And then I have a point, right? 1, 3 is the point on there, so I just plug in that point real quick. So 3 equals 5 times 1 plus b. Subtract 5, so I get negative 2 equals b. Okay, so my equation of my line comes from right here. It's y equals 5x minus 2. How can I check to make sure that was right? Oh, I can graph it. 5x minus 2. Well, yeah, it's tangent right at that point. Beautiful. Isn't that awesome? Isn't that cool?
Not so bad.
Way cool. Okay? Not too bad, right? Makes sense? Okay, so if you can find the derivative, you can find any slope at any point that you want just by plugging it in, and then life is pretty good. Okay? Now there's some that don't work, obviously, and we'll have to get a little bit more into that as we go here. Let's do one that's a little tougher. I know. As if this isn't hard enough in the first place. Hey, you guys should be happy we're actually doing calculus.
Do you remember last year's how when we began, it got to a point where we would just start out through the bleachers and stop?
Wait, can you explain it again?
What happened this year? We're going all the way around, and the kids in the front not knowing what they're doing, just assuming it's the same every day.
Yeah, and everybody's staying together. I actually like it. It looks like a team. It's kind of cool.
Yeah. Emily, it sucks.
No, it doesn't suck. It's not that bad.
I know. I was just wondering.
Okay, that's what this graph looks like if you were to graph it. Well, you'll end up graphing it in a little bit. All right, let's go ahead and find the derivative of this function. That means find the slope generator. Okay, find some equation that's going to generate slope for us at any given point, no matter what. Okay, we're going to have kind of a weird little concept that's going to hit us on this one, and we're going to try to figure it out as best we can. The point I'm going to be concerned about in this one is going to be the point 4,2. 4,2 should be a point on that graph. Plug in 4, get 2. Makes sense. Okay, so I got to find the derivative of that function. Okay, so we're going to plug in that whole big mess, f of x plus h minus f of x over h. Okay, so I'm going to plug in an x plus h in there first. So that's the square root of x plus h. And we're going to subtract the square root of x, and then we're going to divide that by h. Okay, so that doesn't seem too bad, I hope, right? At least the plug-in. How to solve this is going to be a little more challenging, right? I still can't do the limit as h goes to 0, right? I can't just plug in a 0 for h. I would get 0 over 0, indeterminate, right? So how can I fix this numerator? What's an option?
Conjugate.
Can't square it. It's conjugate. Yeah, exactly. Do the conjugate of this guy, which we've done a couple problems like that before. We're going to conjugate that. We're going to go the square root of x plus h plus the square root of x. Top and bottom. Okay, so this will simplify this real nicely for us, hopefully. Okay, so the numerator, I just FOIL that out. Actually, inside and outside cancel, so I don't have to do all of FOIL, just the first and last. So square root of x plus h times itself is x plus h. So that's x plus h. Subtract square root of x times square root of x is just an x. Divided by this big mess here. H, square root of x plus h, and then plus the square root of x. Good stuff's going to happen, right? Maybe? Oh, x is cancel. Awesome. Oh, h is cancel. Okay. X plus the square root of x. Awesome. Now here's the math going on behind here. We get the limit as h goes to 0 of this 1 over the square root of x plus h plus the square root of x. Okay? Well, now I can just do direct substitution. Now I can just plug in a 0 for h. Okay? So if I plug in a 0 for h, I end up getting 1 over the square root of x plus the square root of x. Everybody okay with that? Because that's going to be a 0 for my h. So it's just going to be a regular square root of x. Well, I'll just add those together. So I get 1 over 2 times the square root of x. Okay, so 1 over 2 square root of x is my derivative for this function. That's my slope generator. Okay, that generates slope for me. 1 over 2 square roots of x. Okay, so I just write it up there. Okay, make sense? Kind of? A little bit not. Here is this top section here. Okay, now let's go ahead and let's just make sure that our math is pretty good here. Let's find the slope at the point 4,2 real quick here. Okay, so I'm going to find the slope of the point 4,2. Well, that's pretty easy now. I just plug it into here, right? So I would go f prime of 4. 4 is my x value. So this is going to be 1 over 2 times the square root of 4, which is 1/4, right? So my slope for this guy is going to be a 1/4. So if I went to the point 1, 2, 3, 4, and then up 2, Pretend that's right there. The slope of this line, of this tangent line, is going to be a 1/4. Okay? If you want to write the equation for that line, you just go y equals mx plus b. Y equals mx plus b. And so m is 1/4. Y equals 1/4 x plus b. And then plug in the 4 2. Okay? So 2 is y equals 1/4 times 4. And then plus b. So I get, what's that, 1 subtracts a plus 1. Does that sound right? Yeah, so we should get plus 1. So my tangent line is going to, or my slope of my tangent line, oh no, my tangent line, I said that right, is going to be 1/4 x plus 1. Okay, let's throw those both on a graph, just take a look at it, and then we're going to do some other things. Okay, so we got the square root of x. That's that guy, and then I'm also going to graph this 0.25x plus 1. Looks pretty darn good. That's kind of tough to see just based on resolution, but that's actually going to be the tangent line at that point. Okay, making sense? Not too bad. Okay, so a lot of it's just actually some algebra. Once you plug in, you got to algebraically decide what the heck am I going to do with this. Okay. Now the hard part about this, I think the hard part about all this stuff right here is what happens if I have this derivative is 1/2 square root of x. There's a point on this graph that's at 0, 0. That's this point right there. What's the slope of the tangent line at this point? That's the very end of the graph. Well, just plug in a 0. Ooh. What happens when I plug in? Yeah, it's undefined, right? So I have an undefined slope. Yeah, kind of weird, right? So actually my slope here is going to be an undefined slope. Okay, I can't plug in a 0 right there. I get an undefined slope. Now, if you thought about the slope of this line of my graph right here, oops, sorry. If I thought about this tangent line being moved like this and like this and like this, as it's getting closer and closer and closer to 0, you can see what the slope's getting closer to. It's getting closer to an undefined slope. Yeah. So, anyways. I was losing people. I wanted to do a little more, but I was losing people.